Bismillah ar-Rahman ar-Rahim, my dear students of the course Biopharmaceutics and Pharmacokinetics, third year students, College of Pharmacy, Ajman University. Today we will continue with the nonlinear pharmacokinetic models, and this is part 2, so if you haven't watched part 1, then I advise you to watch it first and then continue with me this session. Okay, let's remember what we talked about in the last session, in the last video. We said that, and I will write it here. We said that the rate of metabolism, or in this case elimination, is equal to what? It's equal to, if you remember, Vm v Cp divided by Km plus Cp, right? طيب. Now, when we give multiple doses of a drug that follows Michaelis Menten kinetic or any other first order kinetics, what happens at steady state? What will happen? Okay, at steady state, if you remember, the rate of input rate will be equal to output rate. This is at steady state. So giving a multiple dose, you will reach a steady state like IV infusion or multiple IV bolus administration. Remember that in multiple IV bolus administration, we said that the dose we give it at steady state gets eliminated during the time interval. The same case applies here. So at steady state, the dosing rate that we give will be equal to the output rate, اللي هو rate of elimination. So in this case, what we can do is we can say the following. The dosing rate, for example, when I say dosing rate, for example, let's say 100 milligram every day or 500 milligram every day will be equal to the output rate. هلا الأوتبوت rate اللي هو the rate of elimination will be equal to Vm في Cp divided by Km plus Cp. Now here I need to add something. Since I'm talking about steady state, the concentration here will be the concentration of the steady state, اللي هي average concentration. So I'm talking about the average concentration. From this equation, we will be able to look at the dosing approaches that we can use in order to calculate what is the dosing rate required for a certain patient. Let's say you are in the hospital and you wanted to start a dosing rate with a patient. You will need to go to literature, okay, and find the population values, the average population values for Vm and for Km. And also you need to look at your target concentration. In this case, it's 15 milligram per liter. This will be your Cp average. Okay. So this is your start. So your start will be to look at the population values, and you can get it from literature, as I said. And when we look at our target, we have to bear in mind what is the therapeutic window. It could be from 10 to 20. In this case, we will use 15 as the target average. طيب, as such, we can use this equation. So our dosing rate will be equal to Vm, which is the maximum rate of metabolism, and don't forget that these two have the same unit always. طيب, dosing rate shul units. What is the units of dosing rate? It's amount per time. For example, I give a certain dose every certain interval, so it's an amount per time. And CP average is a concentration, which will be, for example, microgram per ml or milligram per liter. And Km will have the same units of the concentration. Okay? طيب. In this example, we are talking about phenytoin. And as I said in part 1 video, phenytoin is one of the most commonly described drug, and its pharmacokinetics is frequently described by Michaelis-Menten kinetics. طيب, phenytoin, do you know what is phenytoin for? It's anticonvulsant drug. Okay, so VM is given as 7 milligram per kilogram per day. معناته it relates to the weight of the patient. And the weight of the patient here is 80 kilogram. طيب, as such, what we can do is we can calculate what is the VM for this 80 kilogram patient. So here we have 7 milligram per kilogram every day, and we multiply it by 80 to get VM for this patient. معناته the VM, which is actually from the population data, it's 560. Type 560 what? What is the unit here? Since I multiplied 80 kilogram into this value, so kilogram is removed with this kilogram, so you end up with 560 milligram per day. Okay, so what is your equation now becomes? You have to write as dosing rate. Let me draw it. The dosing rate is equal to 560 milligram per day multiplied في average concentration. What is our target concentration? It's 15 milligram per liter. Okay, divided by Km. Km is given as 5 milligram per liter. So 5 milligram per liter. And as you see here, we need to make sure that it has the same units as the concentration. Plus CP average, our target concentration, which is 15. So in this case, it will be 560 multiplied by 15 equals, and then divided by 5 plus 15, يعني by 20, divided by 20, and the answer will be 420. What is the unit? Okay, I said remember that the unit of dosing rate is the same as VM. So it will be milligram per day. Okay, so this is the answer. So you start giving the patient this dosing rate, and you need to monitor this patient, especially that I'm talking about narrow therapeutic window drug. So let's suppose you monitored the patient and you found out that his CP average is not as you expected, and you found it to be 20 milligram per liter instead of 15 milligram per liter. معناته in your previous calculation, the parameters you entered might not be absolutely correct, because you took it from population, and the patient you are dealing with may be having certain different characteristic in terms of genetic makeup that makes the enzymes responsible for metabolism. فبالتالي you expect that maybe this one is wrong, or both are wrong. Okay, so initially what you need to do is you need to assume, and this is what we usually do, we assume that the VM, because usually the changes between people are for VM more than Km. So we will assume that VM may be incorrect. So what you do here, consider this one, okay, as X. So I have here X multiplied into, and now, okay, let me write it in a different place. Okay, I will write it here. So we will assume the dosing rate that I'm giving, which is 420 milligram per day, is giving me 20 milligram per liter as CP average, and this is multiplied by VM, which I believe maybe it's wrong to assume that it's 560 for the patient. So I will assume that it is X, then divided by, I will assume that Km remains the same. As I told you, why do I do this? Because most of the times it's VM that differs from patient to another patient. So 5 اللي هو Km plus now 20, which is the average that I got. Okay, if you solve this equation for X, okay, which is the VM in this case, you will find that the VM is actually 525. Okay, so your VM will be 525 milligram per day for this patient, instead of a dish, instead of 560. Okay, طيب, which means he has less capacity to metabolize and eliminate this drug. يعني the maximum capacity for eliminating the drug is 525. So use it again, use this new value again to calculate the new dosing rate. So the new dosing rate, new, is equal to VM of CP, VM which is 525, for CP. What is your target? Your target is not 20, your target is 15. What you did here is you changed the VM to describe or to reflect this individual patient. So 525 into 15 divided by 5 plus 15. Okay, if you do this, we'll do it together. 525 multiplied into 15 equals, and then divided by 20, and it will give you a dish. What is the answer? 393. 393.75 unit milligram per day. Okay. Okay. Now, of course, you can give, just as a precaution, instead of 393.75, you can just give 390. But what you will find is that the dosing rate now has decreased from 420 to 393, right? Now this decrease is a decrease of about 5% decrease في dosing rate. يعني from 420 decreasing to 390. Okay, there is about 5% decrease, right? But I am expecting that the average concentration will decrease from 20 to 15. From 20 to 15. This decrease is about 25% decrease field concentration. Okay, So 5% decrease في الدوزنج rate resulted in 25% decrease في ال CP average. Okay? طب, which tells you that if this was a first order kinetic, 5% decrease with dosing rate should produce 5% decrease with CP average, but this is not the case here. 5% decrease with dosing rate resulted in a large decrease with CP average, which is 25%. Okay? طيب, suppose you gave this dosing rate, and after 1 month you decided to measure the CP average for the patient, and let's suppose again that you didn't get your target concentration. معناته it means that your assumption إنه ال VM alone has changed is wrong. معناته both maybe has changed, and how can we deal with this situation? So if you are having two dosing rates, اللي هو dosing rate للنيو هون مع dosing rate الأولد, producing two different CP average. For example, this one is 20 and maybe this one, let's say, is 9 or 7, which is less than the minimum effective concentration. Then what can you do? Well, after that you'll be able to know exactly what is the individual patient, the one that you are treating, what is his or her VM, اللي هو maximum rate of metabolism, and what is his individual KM, اللي هو ايش KM is the concentration at which the rate of metabolism or elimination is half the maximum rate. Okay? طيب, how can we do that? طبعا there are different ways, but you will see that here you have an example where you have two CP average resulting from two dosing rates. Dosing rate 1, which is 225 milligram per day, and dosing rate 2, which is 300 milligram per day. طبعا dosing 1, which is the 225 milligram per day, is producing what? Is producing 8 milligram per liter as average concentration, while the dosing rate 2, which is 300 milligram per day, is producing 27 milligram per liter. طبعا both of them are not acceptable, because I told you for phenytoin it should be from 10 to 20, okay, milligram per liter. So obviously there is a problem with the VM and KM. This individual patient that I'm dealing with is not having the same values as the average population. So the solution for this is to solve the two equations simultaneously. يعني together we solve the two equations اللي هم dosing rate 1 and dosing rate 2 together. We have 225 equals to VM في 8 اللي هو CP average divided by KM plus CP average, and we have the other equation اللي هو 300 equals to the CP average that it is producing اللي هو 27 في VM divided by KM plus the CP average اللي هو 27. So I have two equations. I need to solve them together. So this is one approach. طبعا you can multiply this into this, بصير 225 في KM و 225 في 8. On the other side you have 8 VM. For the second one you have 300 اللي هو had this one. So you multiply this gets multiplied with this one. Okay? as we did here. We multiplied this one, Vm plus 8, with this one. Right. So we multiply the other one, 300 into Km, and 300 into 27, which will be equal to 27 Vm. Now we can use this one, take this one, the first equation, and multiply it by 300. إذن هذا, this, I will multiply this into 300. Why I did this? Because I want to be able to eliminate some factors in the equations. I want the two equations to be similar in some areas, in some terms. طيب, so 300, multiply it into the first equation, so it will be 300 في 225 في Km plus 300 225 في 8 will be equal. Also I have to multiply the other side, 300 في 8 في Vm. Now I can do the same thing with the second equation, but in this case I want to multiply it by what? I want to multiply it by 225. شوفوا, I multiplied one by 300 and the other one by 225. So in this case, multiplying 300 في 225 في Km plus 300 في 225. See, I'm adding here this one. This is I'm multiplying. Okay. And in this equation, what I'm adding or multiplying this one. Okay. طلع. Now when I did this, I was able, and subtracting them, يعني take this one because it has bigger value here, minus يعني this equation minus this equation, subtract. Okay. So 300 for 225 for Km, and I have the same term here. So this goes with this. فبصير عندنا 0. I can remove this and I can remove this. طيب. Now the values here and the values here. With the calculator, you can get the following. 300 multiplied 225 multiplied by 27, this is equal, minus, now I want to see here, 300 multiplied 225 multiplied 8, and this will give me the number, which is 1,282,500. Okay. طيب. Now this will be equal to ايش? I need to get the values for this one, اللي هو 300 في 8 Vm. Get the answer for this one. Let me just copy this. Okay, just let me write it here. So the difference between this and this is this one. Now I want to find the difference between 300 في 8 and 225 في 27. So let me start with the first one. 225 multiplied في 27 equals, and I want to remove this one, minus 300 into 8. This equals 367. So I can say here this equals 367 في Vm. Okay, so this is my equation. طيب بعدين I can calculate Vm will be equal to طبعا this number divided by this number. And it's equal to 348.9, يعني 349 تقريبا. Okay, so VM is equal to 349. Where did it go? 349. Where did it go? Okay, 300. Okay, I have to switch this one. 349. ايش اليونت؟ milligram per day. Why did I use milligram per day? Because the dosing rate is in milligram per day. VM must be the same as the dosing rate. Okay. طيب, once I get VM, it will be, I can use any of these two equations that we talked about. For example, here, I can use the number or the value for VM here, and then the only unknown will be here. طبعا, this is one of the ways. The other way, I will show you how to do the other way for solving the two equations. Now, these are the initial two equations that we have. What you need to know or to do is first find one of the parameter. I either try from one of the equations to find what is VM or Km. Choose just any one of them. In this case, I will use VM. I want to see what VM equals to. Type to solve this simply, we can do the following. Okay. First, let me solve this one. 225 multiplied by 8. So 225 multiplied by 8, and it's equal to 1,800. So now I have 225 km plus 1,800 is equal to 8 VM. طيب, so VM is equal to what? So VM is equal to, now you need to divide this one here and here. Okay, so it's equal to 225 by 8. 225 divided by 8 equal 28.125 km plus, now I need to divide the other one, which is 1,800 divided by 8. So the answer is 225. Okay. Now, so now I know what is VM. Now, in the second equation, don't use the same equation. In the second equation, instead of VM, use this one. اللي هو 28.125 في km plus 225. So what will happen to the second equation? I will say 300 km is plus, now I'm using the second equation, I cannot use the same one. Okay, in the second equation, 300 km plus 300 for 27. So plus 8,100. Okay. 8100 now is equal to 27. Now multiplied for VM. Now what is VM? I will substitute this one. بدل VM I will use this one. اللي هو 28.125 KM في KM plus 225. Okay, now I will multiply these inside and find the answer. So 300 km plus 8100 will be equal to 27.125 multiply it. Okay, let me repeat this one. 27 multiply it في 28.125 equals, okay, I have here 20,000. Okay, I will take the same number. Dash 20,598. 20,598. So 20,598 km plus 27 multiplied 225, it's equal to 6,075. Okay. طيب, now of course we want km to be in one place. This is the smallest, so I will take it this side and I will take this one here. So it will be 8,100 minus 6,075. 8,100 minus 6,075 equals to 2,025. So I will write here 2,025 equals. Now I will take, as I said, 300 km this side, so it will be 20,598. 20,900. Sorry, 500. 598 minus 300, and it will give me 20,298. ايش km. So can I get km? Yes, I can. So if I divide this one اللي هو 20,000, maybe I have a mistake here. Yeah, this is not correct. Okay, I did a mistake. 27 multiplied by 28.125. It's equal. Okay, where did this number come from? Supposed to be 759. Okay, so this is wrong. 759. $759.375. Okay. طيب, as such, if I bring the 300 here, okay, I have to correct this one. So 759.375 0.375 km minus 300 km give me 459 is an here 459.375. I don't know how did I get that number 20,000 something. Anyway, طيب. Now how do I get km? Km will be equal to this number divided by this number. So 2025 divided by 459.375, and it's equal, you'll see it here, about 4.4. What is the unit of km? We said it is the concentration, same as Cp. Cp is in milligram per liter. So once you get your km, which is 4.4 in this case, then you can use any of these two equations, whether this one or this one, to get your Vm. What is your Vm? Or you can use it here as well. So you use 4.4 here to get your Vm. So this is the other way. It's a similar other way. You can use whatever is more convenient to you. So once you get your Km, Vm will be calculated easily. Okay. Now, the other way, which is a simpler way, is using graphical methods. Now, if you go to the books, to the textbooks and literature, you will find that there are different graphical methods that will allow you to easily, instead of going through all these steps, which may be time consuming, it will allow you through a graph, we call it nomogram, to easily calculate the Vm and Km, and even allow you to determine the required dosing rate to achieve the target concentration. إذن instead of running all these equations, في عنا graphical method which allow you to calculate the Vm and Km and the new dosing rate, بس بشرط, only there is one condition. شو هو؟ اللي هو to have two dosing rates زي what we did before. إنه we need to have two dosing rate, 1 and 2, and two average concentrations. If you have this information, you'll be able to calculate or to determine, خلينا نحكي, to determine the Km, to determine Vm, and even determine the third dosing rate that will allow you to get your target concentration. It's very easy and simple method. Look at this graph, which we call it nomogram, which is a graphical calculating device. You will see an axis here starting from 0, okay, vertical axis, and you will see horizontal axis. Now the horizontal axis will be used to put the concentration, okay. This side, اللي هو from 0 and up in this side, okay. طبعا in normal graph paper they will need to be negative, صح? But forget about negative here. We are talking about concentrations. From this side you will have Cp average, okay. Is on this side of axis, horizontal axis, is for pointing the Cp average that you get from any dosing rate, and this side is for determining later the Km. لاحظوا, this is very important, that the distance from 0 to 10 here is the same as the distance from 0 to 10 from this side. Is and there is no negative. The distances are equal for the concentration. This is the side of Cp average, and this is the side of Km. طيب, the vertical axis is for two things. One, it's for determining Vm later, you will see, and second is for pointing the dosing rate. طيب, شوفوا, see what do you have here. طبعا you will see that in this line the dosing rate is 300. هاي شايفينها? This is the dosing rate. So initially what you will do is you will put the dosing rate first. Then if you have a graph, put where is your dosing rate, and then put what did this dosing rate produced fill concentration as average concentration. فإذا you will have two data points. One is here and one is here. This is for the dosing rate 1 and CP average 1. Now go to the next dosing rate. Next dosing rate, you see it here, it's 150 milligram per day, which produced this point. Let me suppose that it is 7. Okay. طيب, so you have two data points here and two data points here. Now connect between these two data points in this line and then extrapolate. خليك طالع. Continue rising, extrapolating the line. Okay? You do the same thing with the second dosing rate and its average concentration. Connect between them and then continue extrapolating. طبعا they will, if it is first order, لو انها first order مش Michaelis, it's not Michaelis-Menten, they will be parallel to each other. But because they are Michaelis-Menten, following Michaelis-Menten kinetic, they will meet at a point. You see this point. Now they will meet, forget now about this dashed line, these two lines, they meet at this point. Now make a horizontal line to meet with the vertical line here, and vertical line to meet with the horizontal line here. So you get this number and you get this one. Now what does this one represent? It will represent for you the value of Km. وشو الفاليو اللي هون? What does it represent? It represent for you Vm. So now you have Vm and Km. طيب, if you have this patient Vm and Km, then you can calculate the new dosing rate. Or if you like, instead of using the equation which says that the dosing rate is equal to Vm, what is Vm? Vm is the one that you determined here, multiplied CP average. This is what you want. For example, let's say you want a CP average of 12 divided by Km. Km is what you got here. Type Km plus your CP average is 12. طبعا you can substitute Vm and Km values and then you can, instead of using this equation, go to the same graph, find out your target. Where is your target? The CP average, it's here. This is 12, let's say. Okay? And then find, انتبهوا, where is your A? Where these two lines unite. Okay, look at this point and then connect between this point and your target, اللي هو هنا 12. So this is the dashed line that connects between A and the target concentration. Now where do they meet the vertical axis? It meets the vertical axis here. طيب, what is this number here? Let's say it's 180. What is this 180? It is the new dosing rate that will produce 12 milligram per liter. طيب, the dosing rate will be milligram per day to produce the target concentration of 12 milligram per liter. طبعا this is the nonlinear pharmacokinetic that is simplified for you to make it easy. It doesn't include everything that is related to nonlinear pharmacokinetic. As I said, nonlinear can result from so many things. Okay, we just looked at one case. Okay, we concentrated on one case that is related to saturated metabolism or saturable metabolism. I hope you enjoyed the video. As usual, if you have any question, please do not hesitate to contact me. Bye bye.